Hi, so for today, we're going to talk about the 1001 solved integral, part 15. So we're going to solve 5 problems for this. Okay. So for the first problem, we have sine of squared x tangent x dx. Find the integral of that. So the first thing that we're going to do here is that since we cannot express this in terms of simple u-substitution, we're going to use some trigonometric identities in order for us to transform this. So we have 1 minus cosine squared of x. Okay, for the sine squared of x plus cosine squared of x equals 1. That's where we get that. Then we have for the reciprocal or the tangent theta. So for the tangent theta, if you're going to recall, that's sine theta all over cosine theta. So that's the identity that we're going to use. So we have sine of x all over cosine, okay, of x dx here. So we just multiply it. So we're having sine of x minus sine of x cosine squared of x all over cosine of x, and we have dx. So we can have this factored out, or at least separate this because of the minus sign here. So we have sine of x all over cosine of x dx minus the integral of sine of x. That should be sine of x. Sine of x cosine squared of x all over cosine of x dx. So as you can see, this will cancel out. So leaving our second integral with a simplified form of integral like this. So you have sine of x cosine of x dx minus the integral of sine of x cosine of x dx. So right now, we can use the u-substitution by letting our cosine of x as u. So the du would be negative sine of x dx. But of course, we only have sine of x dx, so we can have negative du of the sine of x dx. So for this, we are going to substitute it. So we have negative du all over u minus, we have for cosine of x, we have u and sine x dx will be negative du. Okay, so this will be negative ln of the absolute value of u. Negative du times minus here becomes positive u du, or simply u squared all over 2. So you have u squared all over 2 plus c. Going back to its original variable, we have negative ln of the cosine of x plus 1/2 cosine squared of x plus c. So this is our answer for this given integral for number 96. Okay, so pretty easy. Let's move on to the second one. So we have for 97, number 97, we have integral of sine cube of x. Then we have 2 minus 3 cosine of x squared dx. So this is in terms of sine and cosine. But the first thing that I'm going to do here is first to separate one strip of sine to the dx. So I have sine squared of x here. Then we have 2 minus cosine of minus 3 cosine of x. Cosine of x here squared multiplied by one strip of sine x from the sine cube of x. So the reason I did that, it's because this sine of x dx here will be utilizing it in the future as letting it as our du, okay, by letting our cosine as the u. So doing that, okay, Pythagorean identity, I have 1 minus cosine squared of x, and then expanding this one expanding this one, so we have 4, okay, and then minus 12 cosine of x, then plus 9 cosine squared of x multiplied by sine of x dx. So I'm going to multiply first 1, distribute 1 to all of the terms here. So we have 4 minus 12 cosine of x plus 9 cosine of squared x. And then for the second part, I have to distribute negative cosine of squared x, the 3 terms here. So I have negative 4 cosine squared x plus 12 cosine of cube x. Okay, and then we have minus 9 cosine of raised to 4x, and then sine of x dx. Okay, that's how simply we did that. We just distributed, okay, the 1 minus cosine, and then we have already this term. Okay, so if we're going to do this manually, we are seeing some what do you call this? We are seeing some simplifications for this. So we have 4 minus 12 cosine of x, 9 minus 4 cosine of squared of x. That would be positive 5 cosine squared of x, plus 12 cosine cube of x minus 9 cosine raised to 4 of x sine of x dx. Okay, now distributing sine of x dx to all of this term. So I have 4 integral of sine of x dx minus 12 integral of cosine of x sine of x. I've already factored out the constant outside of the integral sign. So we have plus 5 cosine squared of x sine of x dx plus I have 12 integral of cosine cube of x sine of x dx. Finally, we have minus 9 integral of cosine of raised to 4 x sine of x dx. So I've just used the sum and difference and also the constant rule for distributing the sine of x dx in all of the terms. So right now, if I'm going to evaluate the integral of sine of x dx here, it's pretty obvious. Okay, it's very obvious that the integral of sine, okay, would be negative cosine. So that would be negative 4 cosine of x. It's a direct substitution. But for here, for the remaining, we have cosine sine x, cosine sine x, cosine sine x, cosine sine x. I'm going to let u equals cosine of x, and then the du would be negative sine of x dx. Okay? Or what I mean is it's positive. Okay? The du is positive. Derivative of cosine. No, it's the same. It's the same. It's negative sine. I'm sorry. I thought it's integral. But the derivative of cosine is negative sine. And the derivative of sine is cosine. So it's still correct. So in doing that, we have this negative 12 in integral of cosine, which is u. We have dx here also. So that would be negative du. Because if we multiply this by negative 1, we'll be getting a negative du equals sine of x dx. So that's negative du. Okay. So and then we have plus 5. Okay, we have u squared. Since sine of x dx is still negative du plus 12 u raised to 3 because of this. Then negative du. And then finally, we have negative 9 integral of u raised to 4, then negative du also. Okay. So doing that, we have negative 4 cosine of x minus or plus 12 because plus Negative times negative would be positive 12. Then we have u squared all over 2. Then we have plus 5. But this 5 would become negative because of this negative. So that becomes negative 5 halves, or negative 5 u cube or all over 3. Minus, again, because of this negative, multiplied by positive 12, it's minus 12, u raised to 4 all over 4. And lastly, this becomes positive 9 because of the negative du here and negative sign here. So this becomes u raised to 5 all over 5 plus c. So simplifying, we have negative 4 cosine of x, 12 divided by 2, that's 6. So that becomes plus 6 u squared, which is our u is cosine squared x. And then negative 5/3 of cosine cube of x. 12 divided by 4, that's 3. Minus 3 cosine of raised to 4 of x. Okay, plus 9 all over 5 of the cosine of raised to 5 x plus c. So double checking our answer. I think we got the correct answer. So that is our answer. Okay. So that's a long one. Okay, but I hope you're learning it. You are trying your best to understand it. So let's go on to another 98, number 98. For our part 15 of double integral, 1001 integrals. So I'm planning to solve still 900 more problems. Okay, so we have sine raised to 5 of t dt all over, we have cosine of squared t. So the very first thing that we're going to do here is to strip off again another sign. So we have sine raised to 4 of t. Okay, and then we have sine of t dt all over the cosine squared of t. Okay, so the reason why we stripped off is again the sine t of dt, we are going to use it as the du later. So if I'm going to convert sine raised to 4t, okay, so sine raised to 4t, that must be 1 minus cosine squared t squared. Okay, because sine 4t equals sine squared of t squared, of which sine squared of t is 1 minus cosine squared of t squared. Okay, so since it is squared, I also included squared here. So we have sine of t dt all over, we have cosine squared of t. Okay, we have no choice but to expand. So to expand, we have 1 minus 2 cosine squared of t plus cosine raised to 4 of t. Then we have sine of t dt all over cosine squared of t. Okay, so the thing that we're going to do here is that take note that our cosine squared of t equals cosine of t raised to squared. So if I'm going to get the reciprocal of that and multiply it to the whole function above, so this becomes cosine of t raised to negative 2 multiplied by 1 minus 2 cosine squared of t plus cosine raised to 4 of t multiplied by sine of t dt. And if I'm going to multiply it, distribute it, okay? So this will become cosine of t raised to negative 2, okay? Then minus 2, because cosine of t raised to negative 2 and then times cosine of squared of t, this will cancel, okay? Just as like we divided. So this will cancel, and then plus, I have cosine of squared of t. Okay, because of cosine raised to 4 of t plus cosine raised to negative 2 of t, the exponents will add 4 plus negative 2. That becomes cosine squared. Okay, so and then I have sine of t dt here. Okay, and then we're going to evaluate Okay, so we're going to distribute. I have cosine of t raised to negative 2 sine of t dt minus 2 integral of sine of t dt. So plus integral of cosine squared of t sine of t dt. So for this, I'm going to let u equals cosine of t, and my du would be negative sine of t dt. Okay, that obviously leads me to negative du sine of t dt. The same goes like this. I'm going to let u cosine of t, then du is negative sine t dt. Then I have negative du as the sine of t dt. And this is a straightforward integral. Okay, and if we integrate sine, okay, that would be a basic integration or direct integration. So I have u raised to negative 2, then we have negative du all over here. And the integral of sine is negative cosine. So negative cosine of t multiplied by the negative here, this becomes positive 2 cosine of t. Then plus the integral of u squared, then negative du. So power rule. So you have negative u raised to negative 1 all over negative 1. Okay. So plus 2 cosine of t minus u cubed all over 3 plus c. Okay. So that becomes negative of negative. Okay. So that must be positive. Okay. U raised to 1, which is cosine of t raised to negative 1, plus 2 cosine of t minus 1/3 cosine of cube of t plus c. So cosine of t, I can rewrite it as 1 all over cosine of t plus 2 cosine of t minus 1/3 cosine cube of t plus c. Okay, but 1 all over cosine, we know it that is secant of t plus 2 cosine of t minus 1/3 cosine of cube of t plus c. So that is our answer for this given integral. Okay, so that's for number 98. Okay, so for number 99, okay, for number 99, so find the integral of cosine of 5 3z dz all over the sine squared of 3z. Okay, so the common thing that we're going to do here is to strip off whatever is in the numerator and at the same time having a prime exponent. So I have cosine of 4 of 3z multiplied by cosine of 3z dz. Okay, for now, that's what we are going to do all over sine squared 3z. Okay, and of course, I'm going to convert the cosine of 4 raised to 3z equals cosine of squared 3z squared. But I know that cosine of squared 3z is 1 minus sine squared of 3z squared. So I'm going to convert that. So that would be 1 minus sine squared of 3z squared multiplied by cosine 3z dz all over sine squared of 3z. Okay, so the purpose I'm isolating cosine of 3z is for that to become the du later on. So what we're going to do is the same old process that we did, okay, a while ago. So I'm going to get the reciprocal of this. So this becomes sine of 3z raised to negative 2 multiplied by 1 minus sine squared of 3z squared cosine of 3z dz. Before I distribute, I have to expand this first. So I have to expand that first. We will have sine of 3j raised to -2. Expanding that, that would be 1 minus 2 sine squared of 3j plus sine raised to 4 of 3j cosine 3j dj. So distribute. So I have sine of 3j raised to -2. Okay. And then I have minus sine 3j raised to -2 multiplied by sine squared 3j will be cancelled. So leaving 2 here. Okay. And then plus 4 plus -2, that becomes sine of squared 3j. If we multiply these two, that becomes sine squared of 3j because of the property of exponents. Whenever we multiply them, we add the exponents. Okay, so that's going to be our answer for this. Not really the answer, but the simplification of this multiplication that we have done. And then we have cosine of 3j dj. So the same old process, I'm going to distribute cosine 3j. So that becomes what? So it becomes sine of 3j raised to -2 cosine 3j dj minus 2 integral of cosine of 3j dj plus integral of sine squared of 3j cosine of 3j dj. Okay, so this time, for this, we're going to let u equals sine 3j. The du would be 3 cosine 3j dj. Okay, but we all know we only have cosine 3j dj. So this would be d all over 3 cosine 3j dj. The same thing we're going to do here. And this is a direct integral. But again, we will be still employing u-substitution on that because we have 3j. Okay. So if we let u as cosine 3j, the du would be negative sine, okay, 3j multiplied by 3 dj. So that must be what? Negative 3 du sine 3j dj. Or no, it's not probably correct. Okay, we're only getting to let you. I'm so sorry. We're going to let you as 3j only. So the du would be 3 dj. That would be du all over 3 equals dj. So that's what we're going to do that there. Okay, it's just the u-substitution of the input of the cosine. Sorry for that mistake. So this would be u raised to -2. Then you have du all over 3 minus 2 integral of cosine of u. And then the dj is du all over 3 plus this one. You have u squared. And then you have du all over 3. Okay, so factoring out 1/3, we have u raised to -1 all over -1. We have here -2, okay, thirds. Then we have cosine of u du plus we have 1/3 integral of u squared du. So this becomes -1/3 u raised to -1. And the integral of cosine is simply positive sign. So that would be -2/3 sine of u plus we have 1/3 u raised to 3 all over 3 plus c. So simplify. You have -1/3. What is our u here? Our u here is sine 3j. So we have sine 3j raised to -1 minus 2/3. And our u here is 3j. Then we have plus 1 all over 9, 1/3 times 1/3. Then you have your u. What is your u? That is still a sine of 3j. So that is sine cube 3j plus c. Okay. So our answer here is this one. And for our last number, okay, for our last number, 100, okay, this is for our 100 integral marathon number. So we have integral of sine raised to 5x, the cosine raised to 5x dx. So in this case, I have to strip off, cosine. 4x, cosine of 4x, then I have cosine of x dx. Stripping off cosine lets me know that I have to express the other integrand into sine. So I have sine raised to 5x. This cosine raised to 4x is equivalent to cosine squared x squared. Okay, so and that gives me flexibility to convert that into Pythagorean identity. So I have sine raised to 5x, 1 minus sine squared x squared cosine of x dx. Okay, so expand. So we're going to expand this one. So we have 1 minus 2 sine squared of x plus sine raised to 4x cosine of x dx. That's how are we going to do this. Okay, distribute. So you already have sine raised to 5x cosine of x dx minus integral of 2 sines raised to 7 of x cosine of x dx plus integral of sine raised to 9 of x cosine of x dx. So I have already distributed both the sine 5 of x and the cosine of x dx here, so that we can see how we are going to let this or to solve this. So if we let u as sine of x, then the du would be cosine of x dx. It's the same for all. Okay, so the same. So what are we going to do here? We have u raised to 5 du minus 2, and then u raised to 7 to du plus integral of u raised to 9 du. So it's all power rule. So you have u raised to 6 all over 6 minus 2 u raised to 8 all over 8. Cancel. This will be 4. 2 all over 8. That's 1/4. Plus we have u raised to 10 all over 10 plus c. So our answer would be 1 all over 6 sine raised to 6x. Remember that our u is sine of x minus 1/4 sine of raised to 4 of x plus 1 all over 10 sine raised to 10 of x plus c. So this will be our answer for this given problem. And that's all. And I hope you learned something from this video. If you like this video, if you learned something about this video, please don't forget to like, share, and subscribe to my channel for more content to keep you updated with the contents that I will upload in the future, so that it might help you in your studies, in your engineering class or in your calculus class. So thank you so much again, and see you on the next video.